And we have made it to the final lesson of Unit 8. We're talking writing polynomial functions and applications. So when we got to write a function, we've got two different types. Sometimes we'll make you leave it in factored form. Sometimes we'll have you write it out in the standard form. So you have to make sure you read the directions. This first example is writing it in standard form.
So using the given zeros, write the polynomial function in standard form. So step one would be to write the function in factored form.
So that's old news, old hat. We're going to subtract 5, add 2, and subtract 4. So then we get x minus 5 times x plus 2 times x minus 4.
Step two, multiply out to get into standard form.
And now we're back to lesson 8.1, where we are starting off with FOILing. So we got x squared plus 2x minus 5x minus 10. So that gives us x squared minus 3x minus 10 times x minus 4. So now what we're going to do is we're going to go ahead and do the box method over here. So we got x squared minus 3x minus 10, x minus 4 over here. Then when we multiply it out, we get x cubed minus 3x squared minus 10x minus 4x squared plus 12x plus 40. So then when we combine our like terms that fall down the diagonals, we then get a final answer of f of x, don't forget to have that, or y equals. We've got x cubed, negative 3x squared minus 4x squared is negative 7x squared. 12x minus 10x is plus 2x. And then we have our plus 40. And there's our answer. Second type of problem. These are the easy peasy, flop and drop, basically. We got x equals 3 with a multiplicity of 2, and x equals 7 with a multiplicity of 4, leaving it in factored form. So the first thing we want to do, like we did before, is get our zeros. So x equals negative 3, we're going to add 3 to both sides. So we get x plus 3. And x equals 7, we're going to subtract 7 from both sides, giving us x minus 7. So our x plus 3, I'm going to write my f of x out front here. X plus 3 is a multiplicity of 2, and x minus 7 has a multiplicity of 4. Boom. Done. That is it. So those of you that are thinking right now, wow, that's it? Yep, that's it. There's a third type of problem that is slightly more challenging. I do want to show this to you because this is useful to know. So our x is a radical 0, 1 plus the square root of 2, and some of you might be going, I don't understand, isn't that already set up? So here's the catch. We have something called a conjugate. Square root zeros always occur in pairs, which means that my other 0 is going to be 1 minus the square root of 2, because remember, when we solve, we get 1 plus or minus. And you've seen this. And so I want you to put your pencils down right now, because I'm going to go through these steps to find the conjugate, which is what we just did, but I'm going to show you why we aren't going to go old school route. So if you're not listening to this video, you're going to do a whole lot of extra writing, and I'm sorry. So we have x minus 1 plus the square root of 2, and x minus 1 minus the square root of 2. So you would distribute that negative, so you'd really have x minus 1 minus the square root of 2 times x minus 1 plus the square root of 2, and then you would have to FOIL out these trinomials. We are not going to do that, so instead we're going to just erase that, and I'm going to show you how you're really going to do it. It's called using the shortcut, and that shortcut is this. Y equals x squared minus the sum times x plus the product. And so what that means, I'm going to find the sum, and I'm going to label it here. The sum would be 1 plus the square root of 2 and 1 minus the square root of 2. And we're going to add those. 1 plus 1 is 2. Square root of 2 minus the square root of 2 is 0, so the sum is 2. And for the product, we're going to take 1 plus the square root of 2 times 1 minus the square root of 2, which we have two binomials, so we're going to FOIL, which 1 times 1 is 1. 1 times the negative square root of 2 is negative square root of 2. Square root of 2 times 1 is plus the square root of 2. And square root of 2 times negative square root of 2 is negative square root of 4. So now we're going to go ahead and say, oh, negative square root of 2 plus the square root of 2, that cancels. And minus the square root of 4, that's 2. So 1 minus 2, which is negative 1. So now we just put that into our function. So we have f of x, and we said it's x squared minus the sum, so minus negative 1, which is plus 1 times x, plus the
Sorry, it should be 2.
Correct that, change that, you didn't see that. So 1 minus 2 times x, plus the product, which is negative 1, so it'd be minus 1. So
why is it minus 2x?
Because the formula says minus. So that's one of those catches that, remember, when we give you a shortcut or a formula, you have to follow the signs. It's minus because we have a plus and a minus. And because we have a plus and a minus, that middle term has to be that minus. So that's an example. Now the next piece, we got some word problems. These word problems are really easy peasy. We actually saw one on our final because the teacher who Shelley left unnamed who wrote our final decided to throw that question in there, not realizing it was from this unit. So we've got cardiac output of a particular patient can be approximated by the function f of t equals positive 0.0056 t cubed minus 0.22 t squared plus 2.33 t, where t represents the time in seconds after the dye injection on a scale arranged from, or a domain of 0 to 23, and f of t represents the concentration of dye in milligrams per liter. We want to evaluate f of t for t equals 0 and t equals 3 and explain what it means. So that means that we're just finding f of 0 and f of 3. Now, one of the cool parts that we could do if we want to, although this with decimals it gets kind of yucky, would be to use synthetic division. But because we have decimals, I'm not going to do that. But f of 0, so 0.0056 times 0 cubed minus 0.22 times 0 squared plus 2.33 times 0. Well, all of those go to 0, so that's 0. And here we've got 0.0056 times 3 cubed minus 0.22 times 0 squared plus 2.33, oh sorry, not 0, 3 times 3. So then I put that into a calculator. So I've got 0.0056 times 3 cubed minus 0.22 times 3 squared plus 2.33 times 3, and we get 5.1612. So what these mean is that at t equals 0, no dye is in the system or in the heart. And at t equals 3, 5.1612 milligrams per liter of dye is in the body. That's what it means. All right, and the last piece is a combination of the two. We got a word problem here, but I'm giving you this box or prism, and I need you to write the function in standard form to represent the volume. Now, if you remember from geometry, volume is length times width times height, which in our case here would be 3x times 2x times x plus 1. We just need to multiply that all out. So 3x times 2x is 6x squared. We need to take that times x plus 1. Well, 6x squared times x is 6x cubed. 1 times 6x squared is 6x squared. That equals b. And then if I asked you to evaluate it, you could do that, which would just be put whatever value of x in for x and tell me what you get for the volume. So now, got 4, yes, you heard it, 4 word practice problems. We got write in standard form for x equals -2, x equals 2, and x equals 4. Write in factored form for zeros of x equals -2 with a multiplicity of 3, and x equals 4. Write in standard form when you have x equals the square root of 2. Yes, this one will have your conjugate or pair. And x equals -3 with a multiplicity of 2. Actually, I'm going to tell you right now, you can leave that one in factored form. We'll talk about that one in class. And then the word problem, profit P in millions of dollars for a t-shirt manufacturer, can be modeled by P equals -x cubed plus 4x squared plus x, where x is the number of t-shirts produced in millions. Determine the profit if the company sells 2 million shirts. And as always, bring your questions with you to class.